In this unit, we'll learn about the structure of DNS messages. We will also talk about attacking DNS servers or using them. Both the DNS request and the DNS response have the same package structure. Each row in a structure consists of 32 bits, that is, 4 bytes. The first 2 bytes in the first row are the request number, so that a response will have the same number. Then, the next 2 bytes make up a number of flags, which indicates whether it is a request or an answer. Is the application in the recursive method, or can it be in the recursive method? And whether the server is the trusted server for the response. In case the responding server is trusted, the answer contains the requested IP address. Additional values will appear in the following fields, such as the query itself. You can string multiple queries in the same message, the answer or answers, and other values that can be used. Each such field usually consists of a number greater than 4 bytes. Depends on the length of the query or response. In this section, we will talk about the types of attacks on DNS servers. There are many types of attacks on DNS servers, in order to impair their functioning by creating a situation where they cannot provide service, or cause the service they give to not be good enough. The first method is called DNS poisoning, and is often called DNS cache poisoning. This is a computer attack that injects incorrect data of server names and IP addresses associated with them to the DNS system or to its cache. This causes a web page request to be redirected to another, as a result of returning an IP address that is not associated with the original server. The main weakness of the system is that on the one hand, it is a critical infrastructure in computer communications, both at the internal level of the organization and at the level of the entire Internet. And on the other hand, the protocol hardly supports security. The relatively common and also simple attack is impersonation poisoning, or spoofing, by implementing malicious values into legitimate names. An example of such abuse could be phishing. That it's a malicious address injection for a well-known site, say bank.com, on the insufficiently protected DNS server. Thus, the user using the poisoned DNS is redirected to another site that looks exactly like the original site and submits his password and username on the fake fields. From that point on, the attacker can do whatever he pleases. Usually, a computer connected to a network that uses a DNS server provided by the user's organization or the user's ISP. DNS servers are typically deployed on an organization's network to improve its performance speed, among other things by caching memory of query results obtained in the past. Poisoning attacks on a single DNS server can affect service users directly by the hacked server, or indirectly by an application store server, if any. Poisoned records can also be learned on other DNS servers after the process of learning their addresses. Another attack could be a DDoS attack, which floods the root server with artificial traffic by one or many attackers, similar to what we saw in previous units. Such an attack on a root server is considered less effective since local DNS servers have the option to bypass root servers by having the IP addresses of the TLD servers in their cache. Apparently, such an attack on TLD servers would lead to a higher vulnerability potential. Also, DNS servers in general have the ability to filter suspicious traffic according to a variety of criteria. Another attack, named man-in-the-middle, which performs sniffing and manipulation of packets received on the DNS server, will result in a delay in the service and the receipt of an incorrect IP address for the customer. There is another attack in which the DNS server is exploited to perform DDoS on another server by having the client impersonate another IP address and sends a DNS request so that the answer reaches the attacked destination. If implemented a large number of times by multiple DNS servers, this method will result in a flood of requests to the attacked server In this unit, we learned about the structure of a DNS message, types of attacks on DNS servers, and using DNS to attack other servers.